I couldn't attempt it again. I tried to DM you on WhatsApp. I was thinking maybe you wouldn't find it as the right channel for me to use.
Oh, okay. I will check.
Okay.
Aside that, any other questions on the work, on what we have done, or what we did the other time that we met?
Madam,
Yes.
Madam, it seems some couldn't attend, so
If
I
you
don't
couldn't,
know.
it's been the deadline has been extended. So if you couldn't attempt, there's a difference between couldn't attempt and attempted and you were not able to submit. So if you couldn't attempt at all, then the deadline has been extended. You could go back and then make an attempt. But if you started and then maybe you're using Telecel, you had network issues or even what do you call it? ECG decided to visit you and turn off your lights. That's different from you didn't make an attempt at all. So those who have not made an attempt, you can go and then make an attempt. But if you have peculiar issues, maybe you had internet, it's only one attempt. So if your internet gets off, then it means that you are done with your attempt. So I will look at that as well. So if you made an attempt, but due to some reason you could not finish, that is different from you did not make any attempt at all. Aside that, yes.
Ma'am, I just want to find out. Sometimes the assignment and then MCQs on the LMS, you've not treated it yet, but then it seems the deadline is out of the time range within which we treated. Are you supposed to do it anyways, or
just do what you can? It's an attempt. Just do what you can.
Regardless being treated or not.
Regardless.
Yes, madam.
Regardless, yeah.
Thank you.
And also, madam, please, concerning the previous assignment that we had where we are supposed to upload it on the LMS, I don't know, but for me, I had an issue. After scanning everything and converting it to PDF, it was more than 50 megabytes.
How?
And I tried uploading it.
How?
Yes, madam.
How?
I tried uploading it and it wasn't 50.
50.
So, madam, the only option I had was to delete some. And you see the questions, I did it on a page. So each question was scanned on the page.
What are you using to?
50 is too much.
Yeah, I was using the iPhone note app where you have to scan it and turn it to PDF.
I beg, did you write a whole notebook or what?
It's not 50 megabytes.
But my pages were 14. After scanning, the pages were 14.
Even with that, still shouldn't be 50 megabytes.
Oh, well, unfortunately, that's what I had. So I wasn't able to upload it on time, and the deadline was almost up. So concerning that, is there anything that can be done, or would it be reopened again?
You have to throw your phone away.
So you can snap 2 pages at a time.
I'm guessing so. You have to compress. I've never encountered such a scenario before where you 14 pages. What kind of is it not the normal cam scanner on phones?
No, I didn't use cam scanner. I used the Notes app. You see, with the Notes app, you'll be able to scan document and turn it to PDF on the iPhone. So that's what I used.
You have to use cam scanner.
Oh, okay.
Yeah, I use cam scanner. That's what I use. Anyways.
Yeah. So, madam, since the class, since it's already closed, would it be reopened again or something?
No, it will not be reopened.
It's gone.
I did go.
Thanks.
Are there any questions aside the assignment? Are there any questions?
Then, madam, please, we are working with you unless you show favor to some of us.
Unless I do what?
At least a revision on what we did last 2 weeks.
A receipt. I'm not sure I'm here. You want receipt?
A revision.
No. We don't know. We don't want to waste it.
Yeah, because I had receipt on what we did. Okay, so not last week. Last 2 weeks we started with limits. We looked at limits at a point, and there's also a limit at infinity. So limit at a point means that we're looking at the behavior of a function as the independent variable x in that function. So given f of x, we are looking at how f of x will behave, or what value f of x will approach as x approaches a certain number. That is what we mean by limit at a point. So as x is approaching a, f of x is approaching what? That is what we're looking at. And then we mentioned that there are two ways, since you're using 2D representation, there are two ways on the number line that given A on the number line, there are two ways that the X can approach A. X can approach A from the negative direction, and then it can also approach A from the positive direction. If from the negative direction is the same as the behavior of the function from the positive infinity direction, then that value becomes the limit of the function. And so we looked at drawing a table where we'll find some values that approaches where x is approaching a. So any number within this neighborhood, any set of numbers within this neighborhood, we put them into the function. If the values are the same, then it means that we pick one of them. So we're looking at f of a from the positive and f of a from the negative. If f of a from the positive is the same as f of a from the negative, then the limit of the function is just f of a. From there, we looked at some properties of properties of limits. We looked at the sum property and then the difference property. So given the sum or the difference of two functions, f of x and g of x, if we are to describe the behavior of the function f of x plus or minus g of x as x approaches a, then we apply the sum or the difference rule, which is limit as x approaches f of x plus or minus g of x. Limit allows us to evaluate the function. All right, so limit means you are evaluating the function. Evaluate the functions individually. So we have limit as x approaches a of f of x plus or minus limit as x approaches a of g of x. Since limit we are just evaluating, all we'll be doing is just substitution. And so with substitution, it means that wherever we see x in the function, we put the a there. So from the first, we'll have f of a plus or minus g of a. And that is how we find limit of function when you have a composition of different functions and the operator between the function is the sum or the difference operator. An example of this is limit as x approaches 3 of maybe x cubed plus 4x squared. To find the limit of this function, we have one function plus another function. We apply the sum property, and the sum property, we apply the sum property because the operator between the two functions is a summation operator. So apply the limit on the first function, x cubed, plus apply the limit on the second, 4x squared. Limit wherever we see x. Limit where.
Please mute your mics.
Limit wherever we see x, we put a 3 there. So from the first part, we have 3 cubed plus 4, 3 squared. 3 cubed, that will give us 27 plus 4 times 9. We have 27 plus 4 times 9, that will be 36, and that will be 63. So when you have an operator between the two functions, or even more functions, finding the limit of such a combination of functions, we use the appropriate property. If the operator is a sum operator, then you use the sum property. If the operator between them is the difference operator, then the property you apply is the difference property. If the operator between them is the multiplication operator, is the multiplication operator or the product operator, then you use the product property. And if the operator between them is the division operator, then you use the quotient property. So it doesn't change. The rules do not change. The only thing that changes is applying what kind of operator do you look for, what kind of operator you see between the two functions or the multiple functions, and then you do substitution throughout. I think the last part that was a little bit challenging was when we are looking at the quotient property, that is limit as x approaches a of f of x divided by g of x. Since the operator between the two functions is the quotient operator, we apply the quotient property, and that is to apply the limit on the numerator divided by apply the limit on the denominator. Limit, we are doing substitution. And so wherever we see x, we are going to put the a there. So this will be f of a divided by g of a, as long as the denominator is not equal to 0. Given f of a divided by g of a, there are 3 possible cases. We looked at these 3 possible cases. Case 1, in no specific order, is when the numerator is 0, but the denominator is not equal to 0. 0 divided by non-zero is equal to 0. Since 0 is a real number, it means that the limit exists and the answer is 0, meaning as x is getting closer and closer to a, the function f of x divided by g of x is getting closer and closer to 0. Example of this is when you have limit as x approaches 3 of x minus 3 divided by 2x squared plus 4. To evaluate the limit, since the operator between the two functions is the quotient operator, we apply the quotient property, and that is to apply the limit on the numerator, limit as x approaches 3 of x minus 3 divided by limit as x approaches 3 of 2x squared plus 4. Since we are doing substitution when it comes to limit, wherever I see x, we put a 3 there. So treating the numerator first, we have 3 minus 3 divided by 2 times 3 squared plus 4. And that will give us 0 divided by 3 squared, that will be 9. 9 times 2, that is 18. 18 plus 4, that is 22. So we have 0 divided by 22, and that is equal to 0. So this means that as x is getting closer and closer to 3, well, so let me write this down. As x approaches 3, the function which is x minus 3 divided by 2x squared plus 4 approaches 0. That is what that means. Then the second case was when we invert them. So for case 2, I have f of a divided by g of a. Case 2 is if I have non-zero at the top, and then I have 0 at the denominator. Non-zero divided by 0, this is equal to undefined. When you have the limits or evaluate the limit and the answer is undefined, it means that the limit does not exist. Example of such a case is if we have limit as x approaches 1 of 4x cubed plus 3x plus 1 divided by maybe x squared minus 1. To find the limit, since there are two functions, I have the numerator function, I have the denominator function. The operator between them is the quotient operator. We apply the quotient property. And with the quotient property, we apply the limit on the numerator. So this is limit as x approaches 1 of 4x cubed plus 3x plus 1 divided by the limit as x approaches 1 of x squared minus 1. Limit in the numerator, that will be equal to 4 plus 3 plus 1 divided by 1 squared minus 1, and that is equal to 8 divided by 0. 8 divided by 0 is undefined. Therefore, the limit does not exist since the answer is undefined. Then the last case, case 3, is I have my f of x divided by g of x when both numerator and denominator are equal to 0. 0 over 0 is said to be known as indeterminate. When we have 0 over 0, which is indeterminate, it means that the original function, which is f of x divided by g of x, limit as x approaches a. The function is not in a form that is easier for you to determine whether the limit exists or does not exist. There will be an answer. All right, so when you're finding the limits of a function in the quotient form and the answer is indeterminate, that is one sure way of knowing that your limit is going to exist or you're going to have undefined. So when you have 0 over 0, we go back to the function and then we simplify the function. The technique we use in simplifying depends on the type of functions that we have. If the function that you have, both numerator and denominator, are all polynomial functions, then the technique we use in simplifying polynomial functions is factorization. So given that both top and down are polynomials, to simplify it, you perform factorization. However, if one of them contains sets or the functions under the square root, then to simplify it, we use rationalization. And rationalization, the first step is to find the conjugate of the set, multiply both the top and then the down by the conjugate, and then you simplify. That is what we did the other times that we met, not physically. If you have any challenges and you watch the video and still don't understand, then we can address it. But for now, we'll be ending on this note, and then we're looking at limit at infinity. All right, so limit at infinity means that this time around, our x, which is the independent variable, is not approaching a specific number a, no, but it's approaching the number plus or minus infinity. Same sample functions, f of x. If the x is approaching a, then we say that this is limit at a point. But if x is approaching either positive or negative infinity, then we're looking at limit at infinity. This is not the same as the limit of a function being undefined. No, this here is an answer describing the behavior of the function as x approaches the number 1. However, if we are looking at the behavior of the function f of x as x is approaching plus or minus infinity, then it means that we're looking at, as the x is getting bigger and bigger, what is the behavior of the function? Since on the number line, I have minus infinity, positive infinity here. We are not looking at the limit at a point A, no. We are looking at the behavior of f of x as the independent variable x is approaching negative infinity or positive infinity. Once again, the limit as x approaches infinity of f of x is equal to a number A. If and only if the limit as x approaches minus infinity of f of x is the same as the limit as x approaches positive of f of x. So for the limit to be defined as x approaches infinity or positive, the behavior of the function must be the same. If the behavior approaching negative infinity is different from the behavior of the function as x approaches positive infinity, then it means that, yeah, the answer you got for the left is not the same as the answer you got for the right. The answer must be the same for both negative infinity direction as well as positive infinity direction. We know that limit, all we are doing is substitution. So irrespective of what the x is approaching, to find the limit of f of x, this will be the same as f of plus or minus infinity. We are only doing substitution. Just that this time around, our x is not approaching a number A. Our x is a huge number in such a way that we are not putting a specific value on it. And that is what the plus or minus infinity means. So given that, we want to find the limit as x approaches maybe negative infinity. Let's do the positive both first. Limit as x approaches infinity of 1 over x. To find the limit of the limit as x approaches infinity of 1 over x, we look at the limit of this function when x is approaching infinity from the negative direction. All right, so we look at limit as x approaches minus infinity of 1 over x, and then limit as x approaches positive infinity of 1 over x. Meaning wherever I see x, we are going to put the value that the x is approaching over there. As x approaches minus infinity, let's treat the first one first. As x approaches minus infinity, we are doing substitution. So this will be 1 over negative infinity. And this will be equal to, since infinity is such a large number, 1 over such a large number. Can someone give us an approximate value for 1 over undefined or 1 over infinity?
Zero. 1 over negative 10.
Really?
0.
1 over 0.
It will not be 1 over 0, but it will be 0. Because infinity is a large number. So 1 over infinity means that maybe you have 1 million people. They are going to share 1 Ghana cedi. How much will each person get? Approximately 0 Ghana cedis. So 1 over undefined is going to be, since I have negative there, 0 is neutral. It is neither negative nor positive. So I can put negative 0 there. Then let's look at from the right-hand side. This will be equal to 1 over positive infinity. 1 over infinity is still 0. So you notice that the same function, which is 1 over x, we are looking at the behavior of this function as x is approaching infinity. So we looked at x approaching infinity from both directions. X approaching minus infinity, x approaching, so I'm going to put plus here, x approaching positive infinity. Meaning to evaluate the limit for both from both the negative direction and then the positive direction. From the negative direction, the answer is equal to 0. From the positive direction, the answer is also equal to 0. Therefore, the limit as x approaches infinity of 1 over x is equal to 0. This means that as x gets bigger and bigger to either plus or minus infinity, or as x gets closer and closer to positive or negative infinity, our function, usually we use y to represent the function if y is 1 over x. Our function y, or f of x, is getting closer and closer to 0. That is what that means. So looking at limit, we are describing the behavior of the function as the x gets closer and closer to a certain number. And in this case, as x is getting closer and closer to infinity, the function, which is 1 over x, is getting closer and closer to the line y is equal to 0. If I graph the line y is equal to 0, what will be the nature of the line? Within this expression here, this here means that as x gets closer and closer to infinity, the function 1 over x gets closer and closer to 0. So there is going to be, as x is getting closer and closer to positive or negative infinity, the function y is also getting closer and closer to 0. So it will get closer to 0, right? But will it touch it?
No.
Therefore, y equal to 0 will be known as
undefined.
So y is approaching 0, not necessarily equal to 0. From the limit that we have just found, limit as x approaches infinity of 1 over x, the answer that we got was 0. We know that this means that as x gets closer and closer, or as x gets bigger and bigger to positive or negative infinity, the function approaches the value 0, meaning it will get so close to y equal to 0, but it cannot touch it. What then is the name given to such a line y is equal to 0?
Y is undefined.
No, not y is not undefined, no. What is the name given to a line that a function can get so close to, but it can never touch it?
Is it parallel?
No.
The limit exists.
Is it an asymptote?
It's an asymptote.
Asymptote.
It's an asymptote. The function gets closer and closer to the line y is equal to 0, but it cannot touch it. Therefore, it's an asymptote. Let's look at what is the nature of this asymptote. Is it going to be a horizontal one? Is it going to be a vertical one? Or will it be a slanted asymptote? If I'm to draw the line y is equal to 0, will it be vertical? Will it be horizontal? Or will it be slanted?
Horizontal.
Horizontal.
Why will it be a horizontal line? Why will it be a horizontal line? Anyone?
Because the x keeps extending.
No. So y is equal to 0 is horizontal in nature. It is a line that the function can never touch, so it's a horizontal asymptote. But why is it horizontal? Given what x is equal to a, this is a vertical asymptote, right? Because if I'm to graph this, it will be a line that crosses only the x-axis, and lines that crosses only the x-axis but never touch the y-axis are vertical. And also because there's no y in this expression here, so there is no way that this line here can ever touch the y-axis. So it is always going to be vertical line. Why is this a horizontal line?
Because it cuts through the y-axis.
The y-axis.
It is a line that crosses only the y-axis. It never touches the x-axis. So it is horizontal in nature, and also because there is no x in this expression here, therefore it is not going to be a line that crosses the x-axis. So it is a horizontal asymptote. Why is it an asymptote?
Because it approaches zero but cannot touch the zero.
No, because it's a line that the function can never touch. That is why it's called an asymptote. An asymptote is a line that a function can never touch. It can get so close to it. From negative infinity to positive infinity, the function can get so close to it, but it can never touch it. That is how come it is called an asymptote. And it is horizontal in nature, therefore we call it a horizontal asymptote. Let's look at more examples, and then we'll look at some techniques that we can use to evaluate the function at evaluate the limits of the function at infinity. So example, limit as x approaches positive infinity or even negative infinity of x cubed. Limit, wherever we see x, what are we putting there? The infinity there. So this will be equal to anyone?
Infinity.
Infinity cube. And what is undefined cube?
0.
Aye.
Still undefined.
It's still undefined. What does this say about the function? Or can anyone tell us anything about what we can see on our screen? We are finding the limit as x approaches infinity of x cubed. Limit, we are doing substitution, so that is all I know for the time being. Therefore, since we are doing substitution, wherever I see x in my function, I am going to put the value that the x is approaching. In this case, the x is approaching positive infinity, or the x is approaching infinity. So I have infinity cubed, that is equal to undefined. What does this mean?
Means it is not touching the y-axis, or?
It is, yes, it is not touching the y-axis, but is it also touching the x-axis? If you find the limit of a function and the answer is undefined, what does it tell you about the function? Does the limit exist?
No.
No.
Does not exist.
It does not exist. So since the limit or as x approaches infinity of x cubed is equal to undefined, it means that the limit does not exist. To prove that the limit does not exist, we mentioned that to evaluate the limit of a function, we look at the value that the x is approaching and then treat it both the negative direction and then the positive direction. If the answer from the positive direction is the same as the answer from the negative direction, then it means that the limit does exist. So if we are finding the limit as x approaches infinity of x cubed, x can approach, well, we can treat this in both the negative infinity direction as well as the positive infinity direction. So we look at the limit as x approaches positive infinity of x cubed, and then the limit as x approaches minus infinity of x cubed. If the answer that we get are the same, then that answer becomes the limit. So here, wherever I see x, I'm going to put the infinity there, positive infinity there. So from the left-hand side, I'm having positive infinity all cubed, and that is positive infinity. From the left-hand side, I'm going to have minus infinity all cubed, and that is equal to the minus infinity times minus infinity times minus infinity. Three of the minuses, two of them will give me a positive, but I'm left with just one more negative. So this will be negative infinity. Same function. If we are describing the behavior from the positive infinity direction, the answer is positive undefined. From the negative infinity direction, the answer is negative undefined. So positive undefined, since it's not the same as negative infinity, it means that the limit of the function does not exist. And that is how come we had the limit of the function to be equal to undefined. So here the limit is undefined because from the negative infinity direction, the answer is negative infinity. From the positive infinity direction, the answer is positive infinity. Since the answer from the positive direction is not the same as the answer from the negative direction, it means that the limit does not exist. Let me give you one, and then you tell me what is happening. Limit as x approaches infinity of 2x squared. What is the limit as x approaches infinity of 2x squared? Anyone?
It's
So infinity.
It will be what?
2 into brackets, infinity, bracket close, squared.
Squared, and this is, what is infinity squared?
Infinity.
What is 2 times undefined?
Still undefined.
Undefined.
The
Yes.
limit is undefined. Therefore, does the limit exist?
No.
It does not exist. What will you use to verify that the limit does not exist?
In the negative.
You take the negative direction.
Yes, and then we come and take the positive direction too.
I take the positive direction. Do we need to verify?
And see.
Yes.
Yes.
Yeah.
What are you getting?
So we'll get negative undefined and then positive undefined.
Are you sure?
It's still positive undefined.
No, you get positive undefined.
You get positive undefined on both.
Yeah.
So both are approaching positive undefined.
Undefined.
So as s get closer and closer to undefined, our function, which is 2x squared, is getting closer and closer to undefined. That is what it means. It is getting closer and closer to undefined. The function is always in the form y is equal to f of x. So this means that as the independent variable x is getting bigger and bigger, or closer and closer to negative infinity and positive infinity, the function is getting closer and closer to the line y is equal to undefined. Meaning that y equal to undefined is what? What kind of asymptote is this?
Horizontal asymptote.
It's a horizontal
asymptote.
So if we are writing that y is equal to undefined is a horizontal asymptote, does the function have a horizontal asymptote?
Come again.
We found the limits of the function. The answer is equal to undefined. Limits, we are looking at how the function will behave as the x gets closer and closer to a certain number. In this case, as x is getting closer and closer to infinity, our function, which is y is equal to f of x given by 2x squared, is getting closer and closer to undefined, right? It's getting closer and closer to infinity, meaning that there is a line given by y is equal to the answer. If I'm to graph this, it's going to be horizontal in nature because a line that crosses only the y-axis. Y is equal to infinity. If it's a horizontal line, does it exist?
Yeah.
Can you draw the line y is equal to 0?
No.
No, man.
Yes, you can draw it.
You can draw it.
You can draw it.
He can draw it. It's a line crossing the origin. Can we draw the line y is equal to 5?
Yes.
Can we
Madam,
draw? Yes.
but equal 0, isn't it going to touch the x-axis?
It will be parallel to it.
Okay.
Parallel lines do not meet. It will be parallel. What about the line y is equal to -5? Can we draw it?
Yes, ma'am.
Yes.
Good.
Yes.
Y is equal to -1,000. Can we draw it?
Yes, ma'am.
What about y is equal to infinity? Can we draw this?
No.
Why can't we draw it? Why can't we draw it?
Because we don't know.
Very good.
Because you know the end.
It's undefined.
Because we don't know what undefined is. From our limit, our answer is undefined. Because both negative infinity direction, positive infinity direction gave us what? Undefined. Meaning that as x is getting bigger and bigger, or as x is getting closer and closer to infinity, the function, which is 2x squared, is getting closer and closer to what? Undefined. We have seen that if the function is getting closer and closer to undefined, it means that there's a line y is equal to the answer, which is undefined, that the function can get so close to but can never touch. And so we are going to draw this horizontal line. It is a line that our function can get close to. But this horizontal line that we are going to draw is of the form y is equal to undefined, meaning that this line we are going to draw is undefined. Therefore, the function has no horizontal asymptote.
Yes.
Yes, you're getting your answer. So no horizontal asymptote. That is what this means. Because the answer we got for our function, the limit answer we got for our function, for both negative infinity direction and positive infinity direction, the answer is equal to undefined. So the limit, does not exist. If our answer is undefined, then it means that the function, it is rolling around, but it's rolling around in such a way that depends on the x. As x is getting bigger and bigger, both negative infinity, positive infinity, the function is getting bigger and bigger, closer and closer to infinity, but it can never touch it because the x is getting closer and closer to positive and negative infinity. So if this is the scenario, then it means that the horizontal line that we are going to construct such a way that our function can never touch is given by y is equal to undefined. We cannot graph this line. Therefore, since we cannot graph this line, it means that the function 2x squared has no horizontal asymptote. Because to draw the only horizontal asymptote you are going to have is the line y is equal to undefined. This line does not exist. It is undefined. Undefined is something that does not exist. Therefore, since it has an undefined horizontal asymptote, the function has no horizontal asymptote. This is not the same as the previous example. In the previous example, we had limit as x approaches infinity of 1 over x. To find the limit of this function, we put the undefined in there, 1 over infinity. 1 over infinity is equal to 0, meaning that as x is getting bigger and bigger from both the negative infinity direction and positive infinity direction, right? We treated this limit as x approaches minus infinity of 1 over x, limit as x approaches positive infinity, of 1 over x. For the negative infinity, I have 1 over negative infinity, and that is 1 over negative 0, but 0 is neutral. You don't have negative 0 nor positive 0. Then for the positive infinity direction, we have 1 over positive infinity. 1 over positive infinity is 0. So for both negative and positive direction, the answer is still 0. Therefore, the limit of the function is equal to 0. If this is the limit of the function, then it means that as x is getting closer and closer to positive or negative infinity, the function is getting closer and closer to the line given by y is equal to 0. Since y is equal to 0 is horizontal in nature, and it is a line that the function is getting so close to but can never touch, it means that it is a horizontal asymptote. This is a line that is defined because the answer is defined. 0 is a defined number. Therefore, the line is defined. Since the line is defined, it means we can draw it. And if we can draw it, then yes, the function has a horizontal asymptote given by the line y is equal to 0. But in the case where we have limit as x approaches infinity of 2x squared, we look at the limit from both negative infinity direction and positive infinity direction. And the answer that we are getting is infinity. So the limit is undefined. If the limit is undefined, it means that the horizontal asymptote that we are going to construct is given by y is equal to undefined. We cannot draw this line because this line is undefined. Since it is undefined, it means that the function 2x squared has no horizontal asymptote. All right, so for it to have a horizontal asymptote, two things must happen. First thing is that x must be approaching either negative infinity or positive infinity. The answer that we are going to have must be a defined answer. Because if it is an undefined answer in this case here, then it means that it will have an undefined horizontal asymptote, meaning there is no horizontal asymptote. But if it is approaching either negative or positive infinity, and our answer is maybe positive 5, then it means that, yes, as x is getting closer and closer to infinity, our function, which is 2x squared, is getting closer and closer to 5, but it can never touch it. Since it cannot touch it, and functions, we write them as y is equal to 2x squared, it means that there's a line given by y equal to positive 5. It is horizontal in nature. The function can never touch it. It can only get close to it. Therefore, it is a horizontal asymptote. Let's take another example, then I will ask some questions. Find the limit as... Yes, please.
I want to confirm something.
Okay.
Since the question we just solved, since y doesn't have a horizontal asymptote,
yes,
because it's approaching infinity, but we are not sure either negative or positive, can we say it's a vertical asymptote?
It will have no vertical asymptote as well.
Okay, sure.
Yeah, there's no vertical asymptote. There is no horizontal asymptote, no.
Okay, thank you.
All right. So,
Madam,
given limit, yes, please.
Please, I have a question.
Okay.
So the example where you gave limits is how do you call it? 1 over x, and the x was negative. Infinity. Can we have like limit is x over 1?
Oh, sorry. X over 1 is the same as x, right?
Okay.
Yeah, so it will be both negative. For the negative infinity direction, we are going to have minus infinity. For the positive infinity direction, we are going to have positive infinity. Negative infinity direction is not the same as positive infinity direction. Therefore, the limit does not exist, undefined. And since it's undefined, it's going to have an undefined horizontal asymptote. Therefore, there is no horizontal asymptote. It is, if you graph this line, it is going to be of this form. This is the line y is equal to x. There's no horizontal asymptote, there is no vertical asymptote. So yeah, 1 over x over 1 is the same as just x. If you invert it, it doesn't change anything. All right, so please give me the limit as x approaches infinity of 3x cubed plus 1, and limit as x approaches infinity of 1 over, let me put a square here, 1 over 3x squared plus 1.
Example 1, it's still infinity.
How did we get the infinity? Wherever we see x, limit, we are doing substitution. Wherever we see x, we are going to put the infinity there. So from example 1, we put the infinity in place of the x. Does the second term carry any weight? Does the second term bring any major contribution?
No, ma.
It doesn't bring any major contribution.
No.
Why doesn't it bring any major contribution?
Because with the 3x minus 3x squared, that other place is infinity plus. So infinity plus 1 is still infinity.
Because the amount of contribution that the first term brings is significantly bigger compared to the amount of contribution that the second term brings. If x is maybe 1 million, assuming the infinity under consideration here is 1 million, then the first term, the amount of contribution is going to bring is the 1 million to the power 2 times 3. That is a whole lot of billions or even trillions compared to that 1 Ghana cedi that the second term is bringing. So you will notice that for expressions of this form, majority of the weight depends on the term that has the highest exponent. If there is a term that has a highest exponent and the limit we are evaluating is x approaching infinity, then this is almost the same as evaluating the limit as x approaches infinity of 3x squared, because not much is being contributed by the second term. As x is getting bigger and bigger, the amount of contribution that the first term is bringing on board is relatively bigger compared to the amount of contribution that the second term is bringing on board. And so to find the limit of expressions of this form, we look at the term by term. The term that has the highest exponent is the term that brings a lot of things on board. Therefore, we can approximate the function to be of the form 3x squared. Because as the x is approaching infinity, you notice that the 1 is not going to change. But the first term, which is the 3x squared, is the term that is going to change a lot. So to simplify the expression, or to even run down the expression, we can run it down to be as 3x squared. And 3x squared, to find the limit, this is always equal to 3x. So I'll have my infinity squared, which is also equal to infinity, because infinity plus the 1, if we have just left it there, would have still been infinity plus 1, which is infinity. So to find the limit of expressions of this form, please, only of this form, look for the term that has the highest exponent. And then you can approximate the entire function to only the term that has the highest power. That does not mean that the other terms do not contribute much, but you look at the amount of contributions from each term. If there's a term that has the highest power, then the function is detected by that term. The rest, they bring a little bit of contribution, but not much as compared to the term with the highest power. So with this same first term, since the limit is undefined, is there a horizontal asymptote?
No.
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 The
No.
answer is very good. The answer is undefined. So if there is going to be a horizontal asymptote, it will be of the form y is equal to the answer undefined. Y is equal to undefined is horizontal. It is undefined. We cannot draw it. Therefore, the function has no horizontal asymptote. Good. What about the second function? The second example. Limit as x approaches infinity of 1 over 3x squared plus 1.
The limit will be 0.
The limit will be 0.
0.
Do we all agree?
Yes, ma'am.
Yes.
All right. So since the limit of the function is equal to 0, what does it mean? It means that as x is getting closer and closer, or as x is getting bigger and bigger, whether negative infinity or positive infinity, the function 1 over 3x squared plus 1 is getting closer and closer to 0, but it can never touch it. Since it can never touch it, it means that there is a line that the function is approaching, given by y is equal to 0. Since this line here is horizontal in nature, and it is a line that the function can never touch, it means y equal to 0 is a horizontal.
Hello, madam.
Yes, please.
Please, I didn't get the last part. You said y is
Y is equal to 0. Yeah, the function, as x is getting closer and closer to infinity, the function y equal to 1 over 3x squared plus 1 is getting closer and closer to 0, but it can never touch it. So there is a line y is equal to 0, which is horizontal in nature, because if you draw this line, it will be a line that is crossing the origin parallel to the x-axis, but it can never touch the x-axis. It's horizontal in nature. It is a line that the function can never touch. Therefore, it is a horizontal asymptote.
Madam.
Yes, please.
Please, when you go to the top, the first question, the plus 1 that you said is insignificant.
Yes.
If we compare to the infinity.
Mm-hmm.
Suppose you maintain it all the way to the end. Suppose you are solving and you maintain it all the way to the end, and still eliminate it. Will you be wrong?
No, you will not be wrong.
Okay, thank you.
You will not be wrong. No. Okay, so let's look at another example. We have limit as x approaches infinity of 5x minus 2 divided by 3x plus 9. If we are to evaluate this limit, to evaluate the limit, we are just, wherever we see x, we are putting the infinity there. Since in all cases, if there is no denominator, even if there's no denominator, the limit becomes undefined. It's always infinity. Let's look at some other cases. Limit as x approaches infinity. Limit, we are only doing substitution, and then we just simplify. So my first step will be to apply the limit on the numerator, and that will be 5 times infinity, whether it is the positive infinity or the negative infinity, minus 2 divided by 3 times infinity plus 9. 5 times infinity, that will be infinity minus 2 divided by infinity plus 9. And this will be undefined divided by undefined. What is undefined over undefined?
Undefined.
Ha 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 ha.
Madam, zero.
Zero.
It's not.
Zero.
It's not 0. It's not 1.
It's 1.
No.
It's undefined. Undefined.
No, it's not undefined. It's called indeterminate.
Indeterminate.
Hey.
Like 0 over 0.
Yeah. It is indeterminate. It is not undefined. You picture this. Undefined over undefined. They are dividing, right? Division means we are sharing. So undefined divided by undefined means you have undefined number of people. Denominator. Going to share undefined amount of money. Determine how much each person will get. It's indeterminate. You don't know the defined number of people. You don't have a defined number of people. You don't have the defined number of items or defined amount of money they are going to share. So this is indeterminate. When you have indeterminate, what does it mean? You are evaluating the limit of a function. The answer you're getting is undefined over undefined. This is known as indeterminate. Quickly, what prompts your mind? What does it tell you about it?
But
You have to
does
go
it
back
mean that the
and
limit does not
simplify
exist?
the
No, it
again.
does not mean that the limit does not exist. The limit does not exist if the answer is simply undefined. But you have undefined over undefined, which is indeterminate. When you are evaluating the limit of a function and the answer is indeterminate,
Madam,
what it tells you need to go back to the function and then simplify the function.
Yeah.
All right, so go back to the function and then you simplify the function. To simplify the function, the technique we use here is slightly cheaper compared to the technique in the earlier one examples from last 2 weeks ago. When the x is approaching infinity, to simplify the function, when you have indeterminate, we divide both numerator terms and denominator terms by the highest power. By the x with the highest power appearing in the denominator. All right, so once you have undefined over undefined, indeterminate, it means go back to the function and simplify it or rewrite it. When the x is approaching a point or a real number, to simplify it, you look at the type of function you have. So far, we've looked at when you have polynomials, you perform factorization. We also looked at when you have sets, then you perform rationalization. However, since the x is not approaching a point or a number, but it is approaching undefined, the technique we use in simplifying the function is go into the denominator function, locate the x with the highest power, and divide all the terms, both numerator and the denominator, by the x with the highest power appearing in the denominator. So in this scenario, since our limit is approaching infinity of 5x plus divided by 3x plus 9, the answer is undefined over undefined. Undefined over undefined is indeterminate, meaning that we need to go back to the function and then simplify it. To simplify this function, since we have not done differentiation to use L'Hopital's rule, to simplify this function, we go to the denominator and locate the x with the highest power. Divide all the terms in the denominator by that x, divide all the terms in the numerator by that x, simplify, and then reapply your limit. So in this case, we have limit as x approaches infinity. Let me write down my numerator divided by my denominator. The highest power of x appearing in the denominator is just the x. So we'll divide this here by x, divide this here by x, divide here by x, and then divide here by x. And then we simplify. Look for the x with its highest power in the denominator and divide all the terms, both denominator and numerator, by that x. So here, this gives me the limit as x approaches infinity. I'll have x divided by x. We can cancel some of the terms out. X here, 1, x there, 1. Here, we can cancel x here, 1, here, 2, x there, 1. In this term here, there are no x's I can cancel out. In this term here, there are no x's that we can cancel out. So it means that when it comes to the cancellation, we are done. From the first term, 5x divided by x, we are left with just 5. Minus, in the second term, we have 2 over x divided by, in the denominator, the first term, since I've been able to cancel the x's out, we have 3 plus, in the second term, I've not been able to cancel any of the x's out, so I will have 9 over x. Now you can reapply your limit. Limit, wherever we see x, we are going to put the infinity there. So from the first, the numerator, I'll have 5 minus 2 over undefined divided by 3 plus 9 over undefined. This is equal to 5 minus 2 over undefined will be 0 divided by 3 plus 9 over undefined, that will also be 0. So the answer is equal to 5 divided by 3. So the limit does exist. It is equal to 5 over 3. So limit as x approaches infinity of 5x minus 2 divided by 3x plus 9 is equal to 5 over 3. This means that as x is getting closer and closer to whether positive or negative infinity, our function, which is 5x minus 2 divided by 3x plus 9, is getting closer and closer to 5 over 3. But it can never touch it. Therefore, there is a horizontal line, y is equal to 5 over 3, that the function can never touch. And since it can never touch it, it means that it is an asymptote, it is horizontal in nature, and so it means that this function, 5x minus 2 divided by 3x plus 9, has a horizontal asymptote given by the line y is equal to 5 over 3. All right, so to evaluate the limit of the function as x is approaching infinity, when you have the function in the quotient form, apply the limit on the numerator, apply the limit on the numerator, apply the limit on the denominator. In this example, we are having undefined over undefined. Undefined over undefined is indeterminate. When the answer is indeterminate, we have seen from the limit at a point that when you have indeterminate, it means that you need to go back to the function and simplify it. In the type of limit, with the type of limits we're looking at, we are looking at the limit as x is approaching infinity. So the technique we use in simplifying a function when the answer is indeterminate is to go to the denominator, look for the x with the highest power, divide every term in the denominator as well as the numerator with that x with its highest power. In this example, To simplify the function, because we are getting indeterminate, we go to the denominator. The highest power of x appearing in the denominator is the x. So we divide the 3x by x, we divide 9 by x, we divide the -2 by x, and we divide the 5x by x. After doing that, we see that there's x here, there's x there, we cancel it out. There's x here, there's x there, we cancel it out. These are the only things that we can cancel out. After canceling, we are left with 5 minus 2 over x divided by 3 plus 9 over x. Now we can apply the limit one again. Limit, we are doing substitution. Therefore, wherever we see x, we are going to put the undefined there. So from this case here, since there is no x here, I'll maintain my 5 minus 2 over undefined. 2 divided by undefined, the answer is equal to 0. So we have 5 minus 0. Then from the denominator, 9 over undefined is going to be 0. Then we'll have 3 plus 0, and that is 3. So the limit is 5 minus 0, that is 5. 3 plus 0, that is 3. So the limit is 5 over 3. Since x is approaching infinity and the function is approaching 5 over 3, it means that the line y is equal to 5 over 3, it is horizontal in nature. It is a line that the function can get so close to, but it can never touch. It will mimic it. It will look as if it's touching it, but it can never touch it. It can never touch it, therefore it is an asymptote. And since an asymptote is horizontal in nature, it is known as a horizontal asymptote. Let's take one more example. I'm sure you have a million questions by now. Limit as x approaches minus infinity, whether positive infinity or negative infinity, both should work. X cubed minus 2x squared plus 1 divided by 9 minus 2x. And then let's take an interesting one. Limit as x approaches negative infinity of 5 plus 2x minus 3x squared divided by 4x squared. So let me make this a cube. 4x squared plus 9x minus 2x cubed. All right, so let's look at these two examples. To find the limit as x is approaching minus infinity, whether it's minus infinity or positive infinity, they should work in both ways. Limit, we are doing substitution. So let's start with the left-hand side. To evaluate the limit, wherever we see x, we are going to put the minus infinity there. Since we mentioned that, looking at the top, you notice that although there are other terms, if you compare the amount of effort each term is bringing, x is getting bigger and bigger. Therefore, since the amount of effort the first term is contributing compared to the other terms is significantly higher because the x has the highest exponent, we can simplify this as limit as x approaches infinity, or we can approximate this as limit as x approaches minus infinity of 7x cubed divided by, looking at the denominator as well, if we compare the amount of effort contributed by 9 and that of minus 2x, you realize that the second term brings a lot more of effort compared to the second term. You could leave it like that and solve it, but to make things easier on ourselves, we can simplify it this way. So from the denominator, I could also have minus 2x. If we apply the limit, this will be 7 times minus infinity cubed divided by minus 2 times minus infinity. And that will be equal to minus infinity over minus infinity or positive infinity. So we'll have minus infinity over infinity. Infinity over infinity, that is indeterminate. Since the answer is indeterminate, it means that we need to go back to the function and simplify it. To simplify it, we look at the value that the x is approaching. Since x is approaching infinity, an asymptotic number, to simplify this, we go to the denominator, look for the highest power of x appearing in the denominator, and divide all the terms in the denominator, divide all the terms in the numerator by this higher power of x appearing in the denominator. So this is the denominator. The highest power of x appearing in the denominator is just x. Therefore, we need to divide both numerator and denominator by this term. So to simplify, we have limit as x approaches minus infinity of my 7x cubed minus 2x squared plus 1. We could still drop the second and then the third term, but let's keep it for fun. Divided by 9 minus 2x. We divide both top and down by the highest power of x appearing in the denominator, and that is this x here. So we divide here by x, divide here by x, divide here by x, divide here by x, and then here by x as well. Then we simplify. Limit as x approaches minus infinity. X here 1, x there, that will give me x squared. So here I have 7x squared. Then minus x here 1, x there, I'll be left with just minus 2x. And then I have 1 over x divided by 9 over x minus 2. Then we can reapply our limit. In the numerator, this will go to 0, this will be undefined, this is a huge undefined. So the numerator, I'm going to have undefined. Divided by, in the denominator, if I put the negative infinity here, I will have negative 0. 0 has no negative sign. So from the first term, we'll have 0 minus, there's no x here, so I'll just be left with 2. This is equal to infinity divided by minus 2, and that is minus infinity. So the answer is minus infinity. If you find the limit of a function and the answer is undefined, it means that the limit does not exist. Therefore, y is equal to minus undefined would have been the horizontal asymptote. But since this here is undefined, meaning we cannot draw it, y equal to minus undefined, you cannot draw it. Therefore, the function has no horizontal asymptote. Let's look. Yes.
Please, I want to find out, why did you divide through by the x instead of the s cube? So that's the highest.
No, highest power of x appearing in the denominator.
Denominator, okay.
Yes, because it is the term that is dividing the function. You don't pick the highest power appearing in the numerator. No, we pick the x with the highest power appearing in the denominator only, not the numerator.
Okay. Thank you.
All right. Let's look at another example from the. Yes, please.
I also wanted to ask the reason why we dropped at this point, where we started limit of 7 s cubed minus 2 s cubed plus 1. I wanted to know the reason why we dropped the 2 s cubed plus 1.
Because it doesn't contribute much. We are evaluating the limit as x is approaching infinity. Infinity is a huge number.
Okay.
So if you compare how much this term here is contributing with this term and this term, you realize that the first term is contributing significantly a higher amount compared to the other two terms. That is how come I dropped it. But like you mentioned, the other gentleman mentioned, is it okay to maintain it? Yes, it's okay to maintain it, but it is not going to contribute much. The behavior of the function will be detected by the terms with the highest powers. So that is how come I dropped the terms, but you could also leave it there.
All right. Madam, can you please scroll down a bit?
Okay.
Over here too, you were saying when you wrote this expression, the 7x cubed divided by the x, you were saying that we could have just ignored the 2x.
Yeah, it wouldn't have contributed much. Let's do that. Limit as x approaches minus infinity of the 7x cubed divided by the x. Then would have had, that is for the numerator. Then the numerator, we drop the 9 and maintain this, minus 2x. Then we'll have divided by the x. We'll still get the same answer as we maintained it. So here we'll cancel some terms out. Here, that'll be 1. Here, that'll be 1. So from the denominator, I am left with minus 2. From the numerator, x here 1, x here, since this is cube, if I cancel one of them out, I'll be left with the x squared. So from the numerator, I'll have 7x squared. Apply the limit again. Wherever we see x, you put a minus infinity there. So we'll have the 7 into bracket minus infinity squared divided by minus 2. Minus infinity squared, that'll be positive infinity. Positive infinity times 7, that'll be 7 divided by, that'll be positive infinity divided by negative 2, which is the same thing we had when we maintained them. So it doesn't matter whether you are going to maintain them or just remove them. You can approximate it to be the only term that has the highest exponent. If and only if x is approaching negative infinity or positive infinity, but you don't drop the terms if the x is approaching any other real number.
All right.
Hello, ma'am.
Yes.
Hello, madam.
Yes.
Please, can you explain after we are simplified to get 7x squared minus 2x squared plus 1 over x?
2x. Minus
Come
2.
Again. Minus 2x. Yes. So please, can you explain that?
How
I understand how we got it, but if we are to how do we call it? Put the infinity into it, I am thinking we wouldn't get positive infinity.
Are you sure?
Please, let's try it.
Okay, so if I put infinity in the first term, then I'll have 7 into bracket infinity squared. What does that give me?
Infinity.
Positive infinity.
Then over here, I'll have 2 times infinity. That will give me, what is infinity minus infinity?
0.
Hey!
Infinity.
Infinity.
It's undefined. It's undefined.
It's true.
It's undefined. No, it's not 0. It's undefined. Then over here you have 1 over
0.
Yeah, we have 0. So you have undefined plus 0, which is undefined.
Okay.
Yeah.
I understand now.
All right. Let's look at the other example. Maybe you can quickly look at it and tell. There is actually a shortcut.
Minus 3s cubed over 4s 2 minus 2s.
Very good. You can approximate this to be minus 3s cubed divided by minus 2s
cubed.
Then the negative and the negative. Therefore, what is the limit of the function?
It's
It will be what?
Undefined.
Undefined.
No, it will not be undefined. No, look at it. Why are we approximating?
It will be 3 over 2.
3
over 2.
So you didn't do any working, but you know the answer. All right, so that is how come I introduced the simplifying it by eliminating the terms that don't contribute much. It is easier to do it that way, or you can go through the long approach. You always get to this point. So from the numerator, since the function is in the polynomial terms or in the polynomial form, you notice that if you compare the contribution by this, by this, by that, the term that contributes a lot is the third term. So we can approximate the numerator to be minus 3x cubed. Because as the x is getting bigger and bigger to minus infinity, the function will behave as if it is dictated by minus 3x cubed. Then we go to the denominator. If you compare contribution by this, and by that, you realize that the contribution by the individual term, the one that brings a lot on board, is the term with the highest power of x, and that is the minus 2x cubed. Therefore, this expression is just limit as x approaches minus infinity of 3x cubed divided by 3x cubed. 3x cubed over 3x cubed, x cubed, x cubed. So here we have limit as x approaches minus infinity of 3 over 2. Limit of a function, of a constant function, is the constant itself. So here we have 3 over 2. Meaning, to evaluate the limit of the function, if the highest power of x appearing in the denominator and the numerator, if they are the same, and you are evaluating the limit as x is approaching either the negative infinity or positive infinity, if the highest power of x in the numerator and the denominator are the same, then the limit of the function is the coefficient of the highest terms. If the limit is x is approaching either positive or negative infinity of ax maybe to the power 7 plus 9 divided by cx to the power 7 minus 8. If the limit is x is approaching negative or positive infinity, and the function is rational function, to evaluate this limit, we look at the contribution of individual term. In the numerator, you realize that the contribution from the first term is significantly higher compared to the contribution of the second term. So from the first term, from the first function or the numerator function, we can approximate the entire function to be ax to the power 7 divided by, in the denominator, if you compare each individual contribution, then the function is of the form cx to the power 7. I have to the power 7, x to the power 7, x to the power 7. If I apply the limit, this will be a times infinity to the power 7 divided by c times infinity to the power 7. Infinity to the power 7 is infinity, so I have a times infinity over c times infinity. And this will be equal to a times undefined is undefined divided by c times undefined is undefined. Undefined over undefined is indeterminate. When you have indeterminate, it means go back to the function and simplify it. Since our limit is x is approaching infinity, to simplify the function, we don't use factorization. We go to the denominator function, whether we are using this or we are using the approximated form, it doesn't matter. We go to the denominator, pick the x with the highest term, x with the term with the highest power. Divide that every single term in the denominator by that x with its highest power. So since the denominator, I have limit as x approaches either positive or negative infinity. Since in the denominator, the highest power of x is x to the power 7, we'll divide here by x to the power 7, here by x to the power 7, here by x to the power 7, and here by x to the power 7. So this is x to the power 7, x to the power 7, cx to the power 7 divided by x to the power 7, And then I have my minus a divided by x to the power 7. Then we can do some canceling out. X to the power 7, 1, x to the power 7, 1. X to the power 7, 1, x to the power 7, 1. So we are left with the limit as x approaches plus or minus infinity, a plus 9 over x to the power 7 divided by c minus 8 over x to the power 7. Then we can apply the limit. Since there is no x here, limit of a constant is the constant itself. Plus, we put either the positive or negative infinity here. We'll have 9 divided by either the negative or positive infinity. We are going to get either negative 0 or positive 0. But 0 is neutral. So I have 0 here. Divided by limit on the denominator. The c is constant. Limit of a constant is the constant itself. Minus, if we put the limit in the numerator, in the second term, we'll have minus or positive infinity to the power 7. That will be either negative or positive infinity. A divided by negative or positive infinity, that will be 0. 0 is neutral, so I have c minus 0. And that will be a over c. So to find the limit of a function, if x is approaching either positive or negative infinity, if x is approaching either negative or positive infinity of ax to the power 7 plus 9 divided by c x to the power 7 minus 8, the limit is always equal to a over c. The coefficient of the leading term of the numerator divided by the coefficient of the leading term in the denominator. If and only if the degree in the numerator is the same as the degree in the denominator. If the degrees are not the same, then this shortcut does not apply. If the degrees are the same, then the limit is always the number in front of the highest term divided by the number in front of the highest term. That is if the degrees are the same. It doesn't matter how many terms you have in there. If the degrees are the same, the answer is always the numbers attached to the highest term. So for example, if we are to evaluate the limit as x approaches positive infinity of 5x minus 7x cubed divided by 2x squared plus 14x cubed minus 9, to evaluate this limit, we could go through the long approach. Let me put a minus here to make it interesting. We could go through the long approach. The long approach is 1, we can approximate the numerator to be minus 7x cubed divided by, we can approximate the denominator to be 14x cubed. Very good. Then we apply the limit. If we apply the limit, then we'll have minus 7 into bracket minus infinity cube divided by 14 into bracket minus infinity cube, and that will be minus undefined divided by undefined. This is indeterminate. Then we'll go to the term, so we go to the denominator. Look for the x with the highest power. In the denominator, the x with the highest power is the x cubed. So we'll divide here by x cubed, here by x cubed, here by x cubed, here by x cubed, here by x cubed. We could do that with this original function, or we could do that with the approximated function. It doesn't change anything. If we do that with the original function, then we'll have the limit as x approaches minus infinity. Let me maintain my original, minus 7x cubed divided by 2. Oh, my pen is misbehaving. 2x squared plus 14x cubed minus 9. So since the highest power of x appearing in the denominator is this x cubed, I'll divide here by x cubed, here by x cubed, here by x cubed, here by x cubed, and here by x cubed. Then you do some cancellation and simplification. S cubed here, 1. S cubed there, 1.
Minus 7.
X here, 1.
Minus 740.
X squared. Yes. Then x, no, this will be just one of the x's, and all of this will go away. X cubed, x cubed. And so we are left with the limit as x approaches minus infinity of 5 over x squared minus 7 divided by 2 over x plus 14 minus 9 over x cubed. Now we can apply our limits since we have been able to simplify a little bit. So this will be 5 over infinity squared, so minus infinity squared, minus 7 divided by 2 over minus infinity plus 14 minus 9 over minus infinity cube. This is minus infinity squared, that will be positive infinity. 5 over infinity, that will be 0, minus 7, divided by 2 over minus infinity, that will be minus 0, but 0 is neutral. So I have 0 here, plus, I maintain my 14, minus negative infinity cube, that is negative infinity. 9 divided by negative infinity, that is minus 0, but 0 is neutral, so here I have the 0 there. So this is equal to minus 7 divided by 14, and that is minus 1 over 2. We could have dodged all of this approach and just look at the coefficient of the leading term in the numerator. The coefficient of the leading term is the number attached to the x with the highest power. Since this is the leading term, it is the leading term because the term in which the highest power can be found, not because it's the term that is leading the function. So since the coefficient of the leading term is minus 7, the numerator will get minus 7 divided by the coefficient of the leading term in the denominator. Coefficient of the leading term in the denominator is the number attached to the highest power of x, and that is 14. And this is equal to minus 1 over 2. And this is possible if and only if the degree of the numerator is the same as the degree of the denominator. You don't need to go through the long approach. Write down the coefficients of the leading terms, and then that'll give you the limit.
Hi.
So yes, limit as x approaches infinity. Yes, I'm listening, please.
Madam, please, can you
Yes.
come scroll some more?
All right. Should I keep going?
Madam,
Yeah.
the 5 over minus infinity all square. Can't we replace the minus infinity by 0?
Why are you replacing the minus infinity with 0?
But I know we will land at the same answer.
You mean with this?
Yes, the 5 over minus infinity.
5 over minus infinity squared. This will give us 0.
Yes.
What are you saying? Can't we just do what?
Madam, shortcut.
Oh yeah, so that's what I was saying, that the shortcut, you just need to go through all of this. Oh. You don't need to go through all of this. Shortcut, check. If the degree in the numerator is the same as the degree in the denominator, you don't need to go through all of this. The answer is always the number in front of the highest power in the numerator divided by the number attached to the highest power of x in the denominator. You don't need to go through all of that approach. So for shortcut, yes, you can do that. Or you can approximate the numerator to be just minus 7x to the power 3. Because if you compare the contribution of this term and that term, this term here is contributing a lot. So yes, we set this away. Then in the denominator, we compare the individual contribution. Since x cubed will contribute more compared to the x squared term and then the constant term, we can approximate the denominator function to be the 14x cubed. Minus 7x cubed divided by 14x cubed. The x cubed cancels the x cubed, and we are left with the minus 7 over 14. So for shortcut, the answer will always be the number in front of the highest power in the numerator over the number in front of the highest power in the denominator. You don't need to go through the long approach, but you need to go through the long approach if the degrees are not the same. I hope I have answered your question.
Yes, madam.
Now,
All right. So,
what if you have two of the exponents are the same and two
then add them first.
Okay.
An example is over here. To find a limit as x approaches infinity, well, if we look in the numerator function, the x to the power 8 appear twice. Simplify it first. If we simplify it first, then we'll have the limit as x approaches infinity of 3x, 4x8 and minus 2x8. That will give us plus 2x8. Then I have my plus 1 divided by 5x8 minus 1. To go through the long approach, apply the limit. You are going to get indeterminate. After the indeterminate, you come back to the function and simplify it. Then after that, apply the limit again. Shortcut, what is the answer to this?
Madam, it's 2
2
over
over
5.
5.
Why is it 2 over 5?
Yeah.
Because the degrees are the same.
Yes.
So if the degrees are the same, then the limit is given by the coefficient of the leading term in the numerator over the coefficient of the leading term in the denominator. So as x is approaching infinity, the function y, which is equal to 3x plus 2x8 plus 1 divided by 5x8 minus 1 is approaching 2 over 5. Meaning there is a line given by y equal to 2 over 5. It is horizontal in nature. The function can get so close to it, but it can never touch it. So the line has a horizontal asymptote given by the line y is equal to 2 over 5, which is the limit of the function as x is approaching either negative infinity or positive infinity. However, if the degree of the numerator is bigger than the degree of the denominator, so let me do that. So let's do the reverse first. If the degree of the denominator is bigger than the degree of the numerator, then the limit will always be equal to 0. And this is why limit as x approaches either minus or positive infinity will give us the same thing. So this will be ax8 plus 1 divided by bx9 plus 8. Limit, wherever we see x, we put the infinity there. So we're going to have a times infinity to the power 8 plus 1 divided by b times infinity to the power 9 plus 8. Infinity to the power 8, that will be infinity. Infinity times a, that is infinity. Infinity plus 1 is undefined, divided by infinity to the power 9, undefined. Undefined times b, undefined. Undefined plus 8 is undefined. That is indeterminate. When you have indeterminate, it means that you need to go back to the function and then simplify it. The technique we use in simplifying such functions is look for the x with the highest power appearing in the denominator. The highest power of x appearing in the denominator is this x to the power 9. So to simplify, we have limit as x approaches infinity of ax to the power 8 plus 1 divided by bx to the power 9 plus 8. So here we divide here by x to the power 9, here by x to the power 9, here by x to the power 9, here by x to the power 9. 9 and 9 will give us 1. X to the power 8 is 1. X to the power 9, I'll be left with just x here. So these are the only things I can cancel out. Therefore, I'm left with limit as x approaches infinity of a over x plus 1 over x to the power 9 divided by b plus 8 over x to the power 9. If we apply the limit, then from the numerator, we'll have a over infinity plus 1 over infinity to the power 9 divided by b plus 8 over infinity to the power 9. This will give us, what is a over infinity? That will be 0. Plus infinity to the power 9 is infinity. 1 over infinity, that is 0. Divided by, I have my b plus infinity to the power 9, that will be infinity. 8 over infinity, that will be 0. And this is 0 divided by b, which is equal to 0. So when the degree of the denominator is bigger than the degree of the numerator, and the limit is x is approaching either plus or minus infinity, ax to the power 8 plus my 1 divided by bx to the power 9 plus 8. If the degree of the denominator is bigger than the degree of the numerator, the answer is always equal to 0. Such a function will have a horizontal asymptote given by the line y is equal to 0. So if the degrees are not the same, then there are two cases. First case is the degree of the denominator will be bigger than the degree of the numerator. If that is the case, then the function will have a horizontal asymptote given by the line y is equal to 0. And this is because the limit as x approaches either positive or negative infinity of such a function will be equal to 0, meaning as x is getting closer and closer to minus or positive infinity, the function is getting closer and closer to the line y is equal to 0. So check the degrees. When the x is approaching negative or positive infinity, check the degree. If the degree appearing in both numerator and denominator are the same, then the answer is always the coefficient of the top divided by the coefficient of the denominator. But if the degrees are not the same and the degree in the denominator is bigger than the degree in the numerator, then the answer is always equal to 0, meaning the function will have a horizontal asymptote given by the line y is equal to 0. Let me see if you got this. So limit as x approaches minus infinity of 3 divided by x, limit as x approaches negative infinity of 2x plus 1 divided by 6 minus 7x. What is the horizontal asymptote of the first function?
0.
Horizontal asymptote means I want a line.
Y equals 0.
Y equals 0. Why is y equal to 0 the horizontal asymptote for the first function?
The denominator has
Because the denominator, the degree of the denominator is higher than the
Very
numerator.
good, because the degree of the denominator is bigger than the degree of the numerator. The degree of the denominator is 1. The degree of the numerator is 0. Very good. Therefore, this limit here is going to go to 0. Since the limit is approaching, since the function is approaching 0 as x is approaching minus infinity, it means that the function y equal to 3 over x will have a horizontal asymptote given by the line y is equal to 0. What about the second?
Y is
0.
equal to
Y is
2
equal to 2 over
over
minus
minus
7.
7.
Very good. So minus 2 over 7. And why is that so?
Because the degrees of the numerator and the denominator are the same.
Because the degree of the numerator and that of the denominator are the same. So the limit of such a function will be the coefficient of the numerator divided by highest power of x, or the leading term of the numerator, divided by the coefficient of the leading term in the denominator, which is minus 7. Or you could go through the long approach. It will always get you there. Please, any questions?
Madam, how is the
How is the
why did you get the exponent 0 for the first question, the 3x exponent
because
0?
there's no x. Degree is the number on top of the x. The degree, to find the degree of a polynomial, you look for the number on top of the x. Originally, there was no x. But if I'm looking for degree, it means I'm looking for the number on top of the x. So I will have to create an x. But since there was no x, after creating it, I will destroy it by making it x raised to the power 0. That is how come I wrote the x to the power 0. So that will say that, yeah, I have an x, it has a power. The power here is 0, so the degree is 0. In the numerator, so in the denominator, there is an x. It has a power. The power there is 1, so the degree of the denominator is 1. Then I can compare the degrees and say that since the degree of the denominator is bigger than the degree of the numerator, the answer would be 0. So I created it because I wanted to compare the degrees.
So, madam, please, we can always choose this approach over the longer one.
Yes, you can always choose this approach. Check the degrees. If they are the same, then the answer is given by the number in front of the highest power in the numerator divided by the number in front of the highest power of x in the denominator. If the degrees are not the same, first case is if the degree in the denominator is bigger than the degree in the numerator, the answer is always equal to 0. And we'll have the horizontal asymptote given by the line y is equal to 0. Next time, we'll look at when the degree in the numerator is bigger than the degree in the denominator. Any question? I do believe.
So, madam, knowing
Yes.
that the degree of the denominator is equal to 0, no, is bigger than the numerator, and then the answer is always going to be equal to 0. So why don't you just write equals 0? Then we'll just forget about the long.
And that's what I said, that if the degree in the denominator is bigger than the degree in the numerator, your answer is equal to 0.
So with that, we just have to write equal to 0. We don't have to follow all these procedures.
No, you don't.
Falaman.
You don't need to.
Okay.
And if the degrees are the same, like on the right-hand side here, if the degrees are the same, you just write 2 over minus 7. You don't have to go through all the long approach.
Even in session B?
Yes,
Hey, no, that one there you have to.
Oh, man, that's what you are saying.
That's what you are saying,
No.
Madam Grace, please, can you scroll up for me?
Okay.
Okay, it's okay.
Are you writing?
Yeah, I want to write something down.
No, I'll
They'll
send
send it to us.
I'll
Yeah.
send it all to you. The major thing is you understand it, and then I'll send the board. Our time is.
Somebody said nominator. What is nominator?
Yes, Madam, go on.
Yeah, I'll send the board to you.
Madam, thank you.
Okay. I think our time is up. I will let you rest a bit and then read ahead of your next lecture. We'll meet again next week.
Okay, madam. Thank you very much.
I'll be sending the board very soon.
Okay, thank you.
madam.
All right.
Thank you, ma.
Charlie, next time.
Bonnie Ben Pan and Nipayo. Bonnie Ben Pan and Nipayo. Oh.
Can anything be done about the assignment? The assignment.
For run away.
Hold on, please. Please, hold on. Relax. Let it sink.
I beg, who get ice water for them?
Yeah, flashing toilet. Let it sink. Yeah, flashing toilet.
The assignment.
Bonnie Ben
The
Pan and
recording is still
Nipayo.
in session. The recording is still in session, please.
I now understand why Abetan sign and it's when you need to do. How for you, pan? When you know she not do.
Bonnie Ben Pan and Nipayo. Oh.
Control S.
What's into it? Why always X and Y?
Bonnie Ben Pan and Nipayo. They be a Nipa see to do the asymptote.
This asymptote in area. You go to sign names here. So the next one is critical thinking.
Darling, myself cry. I made that. Me share the gas. I say in the family.